Hi, everybody. We are going to talk about section 6 from chapter 2. This is on page 23 of your notes. We are actually going to skip example 1, and we're going to be talking about solving systems of linear inequality. So up until now, we've been talking about solving systems of equations. Now we're going to talk about solving systems of inequalities. When we solve a system of inequalities, a lot of times the solution set ends up being a polygon, like a triangle or a quadrilateral or a hexagon or something like that. So a polygonal convex set is the polygon created by the boundary. It's supposed to be a note right there. By the boundary of a system of inequalities. All right, so when we look at example 2, our first system here, it says solve the system of inequalities by graphing and name the coordinates of the polygonal convex set. So that's name the coordinates of the set that results when we get our solution. So our first equation or inequality is x is bigger than or equal to 0. So remember, if it's like x, so what you're going to do is you're going to basically graph x equals 0, and then you're going to shade anything bigger than or equal to 0. And then here you're going to graph y equals 0, and then you're going to shade anything y values bigger than or equal to 0. Then you're going to graph this boundary line and shade everything less than or equal to that line. So when you're graphing, if you have a greater than or equal to or a less than or equal to, you're going to have a solid line, a solid boundary line. And if you have a greater than or a less than, it's like having an open circle, but we can't have an open circle. It's just going to be dashed instead. So a dashed boundary line. So when we graph x is bigger than or equal to 0, and I'm just going to do a scale of 1 on here, I think, for my graph. So if it's x is greater than or equal to 0, then it's going to be a vertical line through 0. So when it's just an x, it's a vertical line and it's going to be solid. So that would just be my y-axis. And I'm going to try to graph this with this pen and not be too messy. Do not have a steady hand. Okay, now I want to shade on the side of this line where the x values are bigger than or equal to 0. So I want to shade to the right of this line. Now I'm not going to shade right now, because if I shade right now and then I graph my other lines, it's going to be really hard to kind of tell what's going on. But I'm going to want everything to the right of this line to be shaded in the end in my final solution. So that's this one here. It's my pink. All right, y is bigger than or equal to 0 would be a horizontal line through 0, which just ends up being our x-axis. So this is my y is bigger than or equal to 0. So I want to shade on the side where the y values are bigger than or equal to 0. So on the side of this line where the y values are bigger than or equal to 0 would be up here above. So I need to shade above this line. So I'm going to need everything above this line. So right now, if I just wanted the solution of when you're bigger than or equal to 0 and for x and y, it would just be this first quadrant. But then we also want to graph x plus y is less than or equal to 5. There are two different ways we could do this. One way would be to put this into slope-intercept form by subtracting the x. The other way to graph this is using the intercepts. So if you want to use the intercepts happen when, something's on the x-axis. An x-intercept is when y is 0, and a y-intercept, point along here, is when x is 0. So basically, I could plug y equals 0 into my original equation and solve for x. So I could solve x plus 0, and I'm just going to solve the equation to get my boundary line, and then the shading comes in when I think about the less than or equal to. When I solve this, I get x is 5. To get the y-intercept, it's that I would put 0 in here for x. So I would be solving 0 plus y equals 5. So my y-intercept is 5 also. So I could graph it either way. If I'm graphing it this way, it's that my y-intercept is 5 and my slope is -1/1 because the number in front of the x is like a -1. So go down 1 to the right 1. So it would be that I start at 1, 2, 3, 4, 5, and then from here I'm going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and so on. If I wanted to graph with intercepts, this would mean my x-intercept is 5, so put a point at 5 on the x-axis. My y-intercept is 5. You see how no matter how you think of it, you end up with the same line. Sorry, I'm not very good at this. I should be using a straight edge, but it's kind of hard to do with this. Maybe there's probably a way to do it. I just haven't figured it out. Okay, and then this is x plus y is less than or equal to 5, or we can think of it as y is less than or equal to -x plus 5. If you think of it this way, then how to shade with it solve for y is you want to shade on the side where the y values are less than or equal to -x plus 5. So if you look at the line and where it hits the y-axis, we want to shade on the side where the y values are less than the line. So are they less than the line up here or down here? It would be down here the y values are smaller. So we want to shade below this line. So I want everything now that does 3 things. I have to be to the right of the pink, I have to be above the green, and below the blue. So the region that would do all of those things would be this, everything in this triangle, this whole thing. So you would shade that whole thing, and that triangle is my solution. Now, the reason I didn't shade as I went is because I would end up then having all this shaded up here, all this shaded here, and then everything below shaded. And it just gets really, really busy when you do that. And so that's why I didn't do that. I just shaded my solution. So what that means is that any point in this region here, if I had the ordered pair, like if I said, okay, 1, 2, if that's a solution, it makes all of these inequalities true. So if I was checking 1, 2, if I put 1 in for x, okay, yeah, 1's bigger than or equal to 0. If I put 2 in for y, yeah, 2's bigger than or equal to 0. X plus y, if I did 1 plus 2, that's less than or equal to 5. Yeah, that's true. So it's that any point in here works, and that's why you have to shade the entire region. So it's anything in here. Also, because these are solid, it's also the dashed lines. Okay, this also asked us to find the vertices of our polygonal region, which would be the corners of this triangle. So here, here, and here. So at 0, 0, 0, 5, and 5, 0. All right, now we also have this thing called the vertex theorem, which says the maximum, I'm just going to write max, or minimum value of f of xy, now we haven't seen anything like that before with an x and y, equals something on a polygonal convex set occurs at one of the vertices. Okay, so we're going to write that down, and then we're going to kind of talk about what we're going to do with that in example 3 here. Because you'll see in example 3 that it asks you to find the maximum or minimum of this rule f of xy equals y minus 2x plus 5. So basically, once we find the vertices, we're going to substitute the x and y into this rule, and whatever coordinate gives us the highest value is our maximum, and whatever gives us our lowest is our minimum. All right, so now let's graph this system, which has, ooh, how fun, 5 inequalities. So you might want to pause the video and go ahead and graph them first. And I think for this one, I'm going to do a scale. I'm going to go by 2s to get everything to fit. So I'm going to go by 2s for my scale. I'm going to assume a scale of 1 unless you tell me otherwise. Okay, so the first one is x is bigger than or equal to 1. So then that's a vertical line through 1. So I'm going to draw it here. Let's see how this yellow shows up. Let's see how close I can get to being through 1. So bad. Okay, so that is my x is greater than or equal to 1. So if I want to be greater than or equal to 1, I have to shade to the right of that. So everything to the right of that. Okay, my next one is y is less than or equal to 8. Okay, so that's a horizontal line through 8. So I'm going by 2. So 2, 4, 6, 8 would be here. So it's a horizontal line. Sorry, so bad. Through 8. It's less than or equal to, so then everything below. So right now we're looking kind of at this region here. All right, so then our next one is 2x plus y is less than 14. So again, you could find the intercepts or you could solve it for y. It doesn't matter. So I'm just going to show you the intercepts just because sometimes that comes in handy to be able to do it that way. And I feel like people aren't always familiar with that method. So I'm going to show it that way. So if I'm finding the x-intercept, y is 0. So if I put 0 in here for y, then that means I have to solve 2x equals 14. So the x-intercept is 7. If I want to find the y-intercept, I'm going to put 0 in here for x. So I have to solve y equals 14. So the y-intercept is 14. So then I would plot at 7, 0. So 2, 4, 6, 7 would be like here. And then 14 on the y-axis. So 1, 2, 3, 4. So up here, right? It's 2, 4, 6, 8, 10, 12 at the very top. And then I want to draw the line that goes through those points, which I'm going to apologize for in advance because I can already tell it's going to be a mess. Okay, so, or again, you could think of this as y is less than or equal to negative 2x plus 14. Sometimes it's helpful to solve for y because then you can pay attention to the inequality that tells you, okay, you're going to go below. You do have to be careful if it's not solved for y because remember with inequalities, if you divide by a negative, it switches the direction of the inequality. So you do kind of want to make sure you're paying attention to like, okay, if I did solve for y, would I divide by a negative? Because if I would, then I have to switch the direction of my inequality. So I need to be below this line because it's less than or equal to. I want to shade on the side where I'm less than or equal to. All right, so then right now I'm below the red, I'm to the right of the yellow, and I'm below the blue. So right now I'm kind of looking at this region here. All right, then I have another line here that's y is greater than or equal to 2. That's a horizontal line through 2. And it's greater than or equal to. And so then it's everything above. So then it's kind of like this trapezoid right here. And then my last line, I need another color. More colors, more colors. Oh, how about this one? Okay. So now for this one, again, I could find the intercepts or I could, this is the same, almost the same as the one from before, or I could solve and do it with the slope. It's going to be intercepts at 5 again. So here's 5 right here. And then 2, 4, 5 would be here. And another terrible line. Okay, now this is greater than or equal to. So this is my x plus y is bigger than or equal to 5, and it's going to be above. So remember before it was this like it was this trapezoid here, but now it's got to be above this line. So then what that means is that my solution is like this kind of section here. And the vertices would be, well, that point, that's fine. This point, this point, this point, and this point. Those would be my vertices. And so that's what I want to figure out next, are my vertices. And once I figure out my vertices, then what I'm going to do is I'm going to find the max and min by plugging into this rule that they gave me, this f of xy. Okay, so my vertices from my graph end up being 1, going over 1 and up 8. And then this next one here, over here, it's over 3 up 8. Now on yours, you can probably tell better than on mine because my scale and my horrible graphing. All right, then I've got right here, this is at 6, 2. Then I've got another one right here. This is at 3, 2. So you want to make sure you're drawing with a straight edge because mine are really hard to tell. And then this one here is at 1, 4. Now, if you were looking at yours and were like, I cannot tell what the solution is, the way you could figure it out really easily is here, I know this was the line x equals 1, and this is the line y equals 8. So this has to be 1, 8. And then this is the line x equals 1, and it's hitting the line x plus y equals 5. So then that means the y has to be 4 because x plus y has to equal 5. So you could solve just quick little systems of equations also to figure them out. So now what we're going to do is using this rule here to find the maximum and the minimum. F of xy means, okay, and you're going to plug your x value in here for x, and then you're going to plug your y value in for y. Oops, I meant to change my color here. Then the y value is going to go in here for y, and then you're going to see when you do that for all of them, which has the biggest and the smallest. So f of 1, 8 would mean I'm going to put 8 in for y minus I'm going to put 1 in for x plus 5. And I'm going to see what that comes out to be, which is 11. Then I'm going to put 3 in for x and 8 in for y. So I'm going to do 8 minus 2 times 3 plus 5, which is 7. Then I'm going to do f of 6, 2. So that means I'm going to put the 2 in for the y and the 6 in for the x. And that's negative 5. And then f of 3, 2, I'm going to put 2 in for the y and 3 in for the x, which is 1. And then for f of 1, 4, I'm going to put 4 in for the y and 1 in for the x, which is 7. So we're trying to find the maximum and the minimum. Okay, the maximum is, well, which of these ordered pairs gave us the highest value, which would be here. And then which of them gave us the smallest value, which is here. So that means this is my maximum and this is my minimum. All right, that takes care of section 6 in chapter 2. Have a good day, everybody.